Hi everyone, in this video I'll be teaching 3 questions that involves surds and Pythagoras theorem. So let's look at question number 1. So they're asking us to find the value of AC squared. So let's look at this triangle. It's a right angled triangle and the value of AB is 9 surd 3 and the value of BC is 5 surd 2. So we can simply find the value of AC by using Pythagoras theorem. According to Pythagoras theorem, for any right angle triangle, hold on, let me draw a little bit larger. Okay, when we try to name the adjacent and the sides as AB and the hypotenuse as C, it's just a random representation. We should know that the hypotenuse is always opposite to the 90 degrees, okay, to the angle which is 90 degree. So from these unknown, we can form a formula according to the Pythagoras theorem, which is a square plus b square is equals to c square. This is the rule according to Pythagoras theorem. So we can use the same rule to find what is AC right now. So in order for us to find AC, we can simply substitute this A with BC, which is BC square, plus with B, which is AB square, which is equals to AC, A and C square, correct? So if we manage to find AC square, we can solve the equation A. So BC is 5 surd 2 plus with AB, I forgot the square plus with AB, which is 9 surd 3 square is equals to AC square. Maybe I just want to swap the position, AC go to left and the rest go to right. So simply I can write it as AC square equals to, if I expand the bracket, it's going to be 5 square, which is 25. And from previous video I did teach, when you want to square any surd, you cancel off the square and you cancel off the surd. So it will be 25 times with 2. Alright. Okay, if you don't understand, maybe I'll just teach you separately how I got this answer as 25 times with 2. Sorry, my handwriting is quite bad. Alright, let's look here. So 5 square, we're going to get 5 square, and surd 2, if I square it, so 5 square is 25, and surd, I can also write it in the form of 1 over 2, correct? So 2 to the power of 1 over 2. Hold on. 2 to the power of 1 over 2, or close bracket and then square it, correct? So any surd 2, surd x or surd anything, if you see the power is 2, you can simply write it as 2 to the power of 1 over 2. If cube root, it will be 2 to the power of 1 over 3 and so on. This is one of the rule, correct? So when we try to expand this 2 inside the bracket, it's going to be 2 over 2. So 2 over 2 is equals to 1. So 2 to the power of 1 is just 2. So we simply need to write it as 25 times with 2. So I believe you can understand why am I writing something like this. So next, it will be 9 square. 9 square is equals to 81. Alright, so 81 times with 3 again, because surd 3 times surd 3 square is just 3. So the answer is going to be 25 times 2 plus with 81 times 3. The answer is 293. Alright. Okay, next they're asking us for B, find the value of tangent x. Okay, tangent x, and write your answer in the form of A surd 6 over B. So first of all, let's try to find tangent x. So according to the trigonometric rule, tangent x, alright, tangent x is equals to opposite over adjacent. Alright, this is according to this is one of the rule according to the trigo theorem. Alright, so when when you want to find x is an angle, correct? So the opposite will be AB and the adjacent is BC, while hypotenuse is AC. So from this rule, okay, from this rule, we need to find tangent x, which is opposite is equals to 9 surd 3, correct? 9 surd 3, which is AB, over adjacent is 5 surd 2. But this is the answer, but we can't leave it like this because they want the answer in the form of A surd 6 over B, correct? So which means we need to make the surd inside this to be 6 instead of 3. So how can we make it as a 6? We need to add another 2, correct? We need to if this 3 we manage to times with 2 is going to be surd 6, correct? So in order for us to do that, we can simply times surd 2 over surd 2 to this, because surd 2 or surd 2 is 1, correct? Which means we are just trying to add something to see what is going to happen. Okay, let's try to solve for this. So the answer is 9 surd 3 times with surd 2 over 5 surd 2 times with surd 2, where surd 3 and surd 2, according to one of the surd rule, remember, we can simply put it as 3 times 2, and this one also the same thing. 2 times 2. Alright, so now it's going to be 9 surd 6, alright, over 5 surd 4. And for this 5 this 4, if we can find it, the answer is 2, correct? So 2 times 10 2 times 5 is equals to 10. So 9 surd 6 over 10, we managed to find the answer already. So by just adding a surd 2, we managed to convert the surd 3 to become surd 6 as what the question is asking us to do. So when we try to compare side by side with A with this thing, alright, A surd 6 over B, so we managed to find that A is equals to 9. This is 9 and not A, alright. B is equals to 10. Yes, we managed to find the answer for question B. Now let's try to find the answer for question C. They're asking us to find the area of the triangle and write our answer in the form of P surd 6 over Q. So first, the area of triangle we can find from the formula, which is 1 over 2, this is for C, times with base times with height of the triangle. Alright, so 1 over 2 times with the base is 5 surd 2 times with the height, which is 9 surd 3. So let's make everything to become one fraction now. So 1 times 5, let's multiply the number first. 1 multiplied with 5, 5 multiplied with 9, which is 45. And then surd 2, we can just put it here, correct? Surd 2, or maybe I'll do it one by one for you to understand further. So surd 2, we can just multiply with surd 3 over 2. Alright, so 45, 2 times 3 over 2, which is equals to 45 surd 6 over 2. Alright, now we got the answer in the form of surd 6 straight away, so we don't need to do anything else. So if we try to compare with P surd 6 over Q from the question, we can say that P is equals to 45, P is equals to 45, correct? And Q is equals to 2. Okay, this is the answer for question C. For part C for question 1. Alright. Now, let's look at question number 2. Find the exact value of surd 2 plus surd 3 minus square root 2 minus surd 3. And they even gave us a hint where they're asking us to let x is equals to the one that we want to find. And then square both sides of the equation. Okay, let's try it out. Alright. So x equals to square root 2 plus surd 3 minus square root 2 minus surd 3, and they're asking us to square both sides. Alright, so let's square both sides. And remember the expansion formula, the one that I taught you in previous video, a plus b, when you want to square it, we can expand it as if a square plus 2 times a times b plus with b square. So we're going to use the same concept right now, where we're going to assume this as a everything and everything else here, on this side as b. So when we want to expand it, we will be getting, first is a square, so everything surd 2 plus square root 2 plus surd 3, and then square it, and then minus 2 times a times b. So 2 times with this thing, which is square root 2 plus surd 3, and then times this thing, 2 minus surd 3, and after that it's supposed to be positive. Why am I putting a negative? Because 2 times positive a and then times with negative, this negative should be included, so it's going to be negative b. So 2 times positive a times negative b, we are going to get negative 2ab. That's why I'm putting a negative here. Alright, So and then negative negative, we'll be getting positive because we need to square it, correct? Okay, when you want to square it, so 2 minus surd 3 square. All right, maybe I'll just wipe this first. Ouch. Now when we want to expand this bracket, we should know that if we want to square a square root and square this, which means the square and the square root, we can cancel off to each other. All right, so the one that is going to remain is 2 plus with I'll change the color, 2 plus with surd 3 and then minus 2. Okay, remember this theory or this formula that I did teach you last time. So surd A times with surd B is equals to surd A times B, correct? So I can make the surd to be together, whereby I can simply write it as if 2 plus surd 3 and then times 2 minus surd 3. And then again, this square root and square can cancel off to each other, where only 2 minus surd 3 is going to remain. Okay, now I forgot to put a close bracket here. So we can see that a plus b times with a minus b. So a plus b, when we want to multiply with a minus b, we can simply get it as if a square minus b square. This is one of the formula. You can try to expand and we'll be getting the same thing, a square minus b square. So I'm going to use the same concept here to find the value when you want to expand this. So 2 plus surd 3 minus 2 square root. All right, so this is a, this is b, correct? So a square, which is 2 square, and then minus with b square, surd 3 square. All right, and then copy back, plus 2 minus surd 3. So it is equals to 2 plus surd 3 minus 2 surd 2 square is 4. 4 minus this surd and square can cancel off, correct? So 4 minus 3 plus with 2 minus surd 3. So let me move it a bit. Okay, now when I want to complete this, so 2 plus surd 3 minus 2 surd 4 minus 3 is 1 plus 2 minus surd 3. So surd 1 or square root 1 is equals to 1, correct? So equals to 2 plus surd 3 minus 2 plus 2 minus surd 3. If you try to complete this, 2 minus 2 plus 2 is equals to 2. Surd 3 minus surd 3 is equals to 0. Therefore, that was x squared just now, right? So x squared equals to 2 and x is equals to square root 2. So this is the answer for question number 2. Now let's look at question number 3. Given that square root 6 minus 4 surd 2 is equals to surd a minus surd b, and find the value of a and b. So let me write it out first. So 6 minus 4 surd 2 equals to surd a minus surd b. And now we need to simplify this on left hand side so that it will become the form of surd a minus surd b, the one that is in right hand side. So what can we do here? Let me look. Now we'll try to solve question number 3, where given that square root 6 minus 4 surd 2 is equals to surd a minus surd b, and they're asking us to find the value of a and b. So let me rewrite first. Square root 6 minus 4 surd 2 is equals to surd a minus surd b. This question is very tricky if you ask me, and we need to use a lot of rule to solve this. Okay, so I did try to solve this question, and I did use this expansion rule to solve it, where a minus b square is equals to a square minus 2ab plus with b square, correct? So if we manage to split this, or if we manage to factorize this in the form of a minus b square, okay, because we do have the square root, correct? So at the end, we can cancel off the square root and the square, and only a minus b will be left off, correct? But now we need to make sure that, or we need to convert the equation inside this square root so that it will become in the form of a minus b square, and which is very hard. So in order for us to do that, we can simply change, or we can simply make it to be like this also, because if we get something, if we manage to change this equation, which is 6 minus 4 surd 2, in the form of a square minus 2ab plus b square, and then we can also factorize this to become a minus b square. a minus b, yeah, square. All right, can you understand? So that's what we will be trying to do now. So first step is, what we can do is we can split this 6 with 2 and 4. 2 plus 4 minus 4 surd 2. Why 2 plus 4? Why not 3 plus 3 or something? Because when I do 2 plus 4, it's easier for me to square root, or easier for me to add a square. For example, this 4, I can simply change it to 2 square, or this 2, I can simply change to surd 4 or something. It's easy for me to play around. All right. Okay, now next step is what we can do. Maybe we should try to rearrange first. 2 minus 4 surd 2 and then plus 4. If you see carefully now, just look, just observe this carefully. Now we almost getting we, after rearranging this, we almost trying to match up with a square minus 2ab plus b square. Why am I saying this? Because something minus something plus something, correct? The same thing here, something minus something plus something. So the sign, we managed to get it correctly. So once we got the sign correctly, now we need to change in the form of a square. All right, so what we can do here, so minus 4 surd 2, we can change this 4 with 2 square, correct? So it will become b square, which is 2 square is b, so 2 is b, 2 can be represented by b, and 2ab and a square. Maybe I can change this with surd 2 and then square it, and then square root everything. Why surd 2? Because remember, surd 2 and square, we can cancel off each other. The answer is 2, so we can get the answer 2, or we can revert back. We can do the reverse calculation to write it in the form of surd 2 square. So if we can see this properly, okay, we can represent surd 2 by a, correct? Or maybe wait, let me do one more splitting. We need to split one more thing, I forgot. So surd 2 square, we need to split this 4 into 2 and 2. Why? I'll explain to you now. Which means 2 times 2 surd 2 is correct. We can split into 2 different things. Why am I doing something like this? Now can we compare directly with a square minus 2ab plus b square? Alright, so if you see carefully, a is represented by surd 2, correct? A is equals to surd 2, and then minus 2 is minus 2, and then ab, and we just mentioned a is surd 2, correct? So surd 2, the a is here, and b is here, 2, and b is represented by 2 as well. So everything does match up, correct? A is equals to surd 2, and then times 2ab, and 2 a is surd 2, b is 2, and b does match up with digit 2 as well. So which means we got everything, and we managed to rearrange everything in the form of a square minus 2ab plus b square. So what we need to do, we need to factorize everything. So if you factorize, we need to make sure it is in the form of a minus b square, correct? And we got to know a is surd 2. So surd 2 minus b is 2, and then square it. Okay, the thing is, we can straight away cancel off this thing, but we need to know that if we cancel off the square root and square, the answer will not be accurate, because surd 2 minus 2, if we try to use our calculator and find, okay, surd 2, hold on, surd 2 minus 2 will be getting, we'll be getting negative 0.585, and then square it, correct? So if, okay, just assume, just look at this way, okay, we can't maybe we can use these rules. According to one of the surd rule, all right, one of the indices rule, if when you want to expand the bracket of negative a with the power of n, we can simply write it as a to the power of n, assuming, okay, n is even, it's an even number. Now n is the even number, correct? If n is even number, we can assume this to be positive. So we need to convert this to become a positive number, not a negative number anymore. All right, so if you want to convert this into positive number, can we simply relocate the position of 2 and surd 2? We can simply write it as 2 minus surd 2 square now. Okay, if you see carefully, surd 2 minus 2, the answer is negative 0.585, correct? This is what we found. When you try to do 2 minus surd 2, you'll be getting positive 0.585. All right, which means we are just changing the sign by changing the position, and according to the indices rule, it does match up. So we can do something like that. Okay, so once we manage to swap the position, maybe some of you will be asking, why can't we just leave it like that? Why can't we why do we need to swap the position? Okay, try to solve this by using your calculator and see what is the answer that you are getting. So 6 minus 4 surt 2, and then if you try to square root it, the answer is 0.585. It's positive 0.585. Alright, if you try to solve straight away without doing all the simplification thing. Alright, which means if you are trying to cancel off the square root and square, okay, you'll be getting the answer in negative form. So the answer will be surt 2 minus 2. The answer is going to be negative 0.585, which is not equals to the answer that we got earlier when we tried to use calculator, which means we need to get the answer in the form of positive value, not negative value. So if you want to convert this to be positive 0.585, we need to simply swap the position. That's it. Okay, that's what I did here. So maybe I'll rewrite everything so you can get a clearer picture. So it's equals to surt 2 minus 2, and then square root it. And then remember, according to one of the indices rule, we can, when we expand the bracket, we can simply write it in the form of a to the power of n. It's positive. So what do we need to do? We just need to swap the position. 2 minus surt 2. So it will become positive. Value inside the bracket will become positive, not negative anymore. Alright. So now we can cancel off the surt and square, which means only 2 minus surt 2 will be left. When you try to minus now 2 minus surt 2, it's giving positive 0.585, which is accurate, which is correct with whatever we found earlier. Okay, now we need to make sure we do match up our we need to simplify so that the question, the answer does match up with this thing, which is surt A minus surt B, correct? So that we can find, or we will know what is the value of A and B. So for the second part, it is already in the form of surt, but for the first part, we need to convert this to become a surt also. So surt 4 is equals to 2, correct? So we can simply convert it like that. So surt 4 minus surt 2, when we compare with surt A minus surt B, so we do know that A is equals to 4 and B is equals to 2. So that is the method on how we need to solve the question, question 3 part A. It seems to be complicated and tricky, but if we sit down and try to do it again and again, maybe you'll get the method on how to solve these type of questions. Alright, now let's solve question 3 part B. Let me rewrite first. So it's the same thing like from part A just now, but now they're asking us to find C and D. So it's square root 23 minus 6, square root again 6 minus 4 surt 2 equals to surt C plus surt D. And the answer for this, we managed to get it from part A. Therefore, I can simply write it as 23 minus 6 square root 2 minus surt 2, correct? This is based on what we got just now. Okay, if I manage to square root one more time, now I can simply cancel off the square root and square, because the answer inside this will be in positive. It will be positive because 2 minus surt 2 is 0.585. All right, so now 23. Oh, sorry. Let me rewrite. So 23 minus 6 open bracket 2 minus surt 2. All right, close bracket, and then rewrite the big surt. And then 23 minus 12 plus 6 surt 2, square root again. Sorry, my handwriting is quite bad. So 23 minus 12 is 11 plus 6 surt 2. Alright, so we need to use the same concept as what we used just now. Alright, hold on. So let's try to do some calculation here, whether it does match up with 11 or not. So first we need to split up this 6 into maybe 3 times 2, or yeah, 3 times 2, that's the best we can do for now, correct? So if 11 plus with 3 times 2 surt 2, I can rearrange this to become 2 times 3 surt 2. Why? We need to make sure it does match up with a square minus or positive or minus or plus 2ab plus b square, because because everything positive now. So when everything is positive, when we factorize this, we'll be getting a plus b square, correct? So we need to make sure whatever we rearrange now, it does match up with a square plus 2ab plus b square, which means 2 has to be at the front. When 2 is at the front, a is considered as 3 and b is considered as surt 2. A is 3, b is surt 2. So if I want to write this a in front, it's going to be 3 and b as surt 2. Okay, now we just need to add a square, correct? So that it does match up with a square and b square. We just need to add a square, and then square here, and then plus and plus. But if we try to add up this thing manually, this and this, okay, if we try to add this up manually, so 3 square is 9, 9 plus with surt 2 square, we can cancel off the surt and square, correct? 9 plus 2, we are getting 11. This 11 does match up with the one that we got here, correct? So what we are doing is correct. We are getting this on the right track. So this 2 times 3 surt 2 is equal to 6 surt 2. This one also does match up with this. So this is based on our it's more like a trial and error. We need to try to do the steps, and then we need to verify with whatever we got. And now it does being verified with what we got, which is 11 plus 6 surt 2. So the method is correct. So now what do we need to do? We just need to simply, okay, let me write equals 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 equals. So first we need to split it up, correct? We need to split this 11 to be 9 and 2. So 9 plus 2 times 3 surt 2 plus with the other part is 2, correct? The other one is 2, because 9 plus 2 is 11. I'm just trying to split these two things so that it will match up with whatever we want. So now this 9, we'll need to make it to be 3 square. 3 square is equal to 9, correct? And then copy back 2 times 3 surt 2, and then this 2 I can simply add a square by making a square root 2, and then square it, I'll be getting 2 at the same time, correct? So now it does match up with what we want. This is a is equals to 3, b is equals to surt 2. So a square, which is 3 square, plus 2a, which is 3, times with b, which is surt 2, plus with b square, surt 2 square. So it does match up with this formula, correct? It does match up with this formula. So when we factorize this, we will be getting a plus b square, which is 3 plus with surt 2 square. This is what we will be getting. Now since everything is positive, it's not negative, we no need to swap the position or anything. So what we can do, we can simply cancel off the square root and surt. We'll be getting the answer in the form of 3 plus with surt 2. But we need to compare with the question. The question asks us to compare with surt c plus surt d, correct? So which is equals to surt c plus with surt d. Alright, this is not in the form of surt, but it's very easy. If you want to change it, just change it to be surt 9 plus surt 2, because surt 9 is equal to 3, correct? And then compare with surt c plus surt d. So c is equals to 9 and d is equals to 2. So this is the method to solve question number 3. It seems to be complicated. I'm telling you guys one more time, it seems to be complicated, but try to sit down and do the question one more time. So you'll be getting we'll be mastering the method on solving these type of questions in future. All right, thank you.